Hello and welcome to another CAD video. This video, I'm going to walk through some tips, tricks, various other, how-tos for things that are on the SolidWorks Certified SolidWorks Professional exam. That certification exam has been around for a while. I've personally never sat for it until just a few days ago. Our educational license comes with several seats where I can just, allow my students to take it and get their certifications. And I thought ahead of having them do that, it would be a good idea for me to take those tests since I never have. It turns out it was a good idea because the first thing that the students ask, of course, what does the test look like? What kind of things are on it? What's the format? And I really didn't know. And so I took it. And I do have to say that I actually took the associate level and the professional level sort of back to back. I will say the professional one made me sweat a little bit. And that was mostly due to the fact that there were some just some modeling techniques on the very first part that I um I don't use very often. So I thought I'd make sort of this video, or depending on how long we run here, a series of videos, sort of walking through some of the tricks, to make this happen. So the first part on that test was this guy, and this is by far the part that took me the longest. And I'm not going to walk through making this exactly. I do want to maintain some of the test integrity. Um, but I'm going to sort of walk through how I went about doing it. And hopefully you can adapt some of those things, to your own modeling in the future. So I'm actually going to go ahead and close this guy because I'm just going to make up mine now. My part, like I said, I'm gonna sort of run through the tips and tricks, and I'm just gonna sort of make up the part on the fly, um, with some of the things that I know they ask, some of the ideas. So the first thing I noticed on all of the problems on the test is that they really, really like the millimeter gram second measurement system. And I'm not ashamed to admit that in my head, I never really converted to metric. I'm still very much think in imperial. So my native SolidWorks environment is in imperial units. So the first thing, though, I would recommend would be to change that for the part you're working on, especially if the test tells you that that's the unit system. That's fairly easy to do, and I don't want to change it for my whole environment. I want to stay in, imperial units. But you can change it document by document just by going up to the menu and tools and way down at options. Now, you could change this at any time. And if you do, and there's a lot of features in this model already, this list will be much longer and you may have to scroll down. There'll be a little arrow down here to scroll down to the bottom, but it's always under tools and options. And we don't want system options. That'll change the entire environment for every part we open from here on out. But we want to change document properties, and that'll just affect this one. And then down here in units, we can just click millimeters grams second. And like I said, the certified SolidWorks professional test, the associate test too, really, both everything was in this unit system. So I'm changing it to that. The second thing I noticed is that all the parts give a material. And they do that because rather than check to see if the part was modeled exactly the way that they did it, what they're actually going to ultimately ask on most of the questions is to give the mass of the part that you end up with. And there's a tolerance, and I forget exactly what that tolerance is. You could be off by a little bit, but by giving a material, and if the model is a reasonable facsimile of what they created, then your mass should match their mass, and you pass the test. So um, they specify it right in the problem statement. So to change material, I'm going to change it right up front. I'm going to come over to my feature manager. I'm going to right click on material. I'm going to edit it. And for the part, like I said, I'm making this up on the fly. I'm just going to pick um, AISI 1020. I don't know. They'll tell you in the problem what they want. I'm going to leave it here. They will tell you what the mass density should be. And I did notice they liked millimeters and grams, but if we switch it to this SI Newton per millimeter, and actually that's not even the right one. Metric, is that the right one? This right here is usually how they will state. So they will state in grams per millimeter cubed. The cool part about metric is that that's the same as kilograms per centimeter cubed. So they'll usually give you this number, and that's how you can verify that you have the right material that they stated. So we can change that right here as well. That'll change the way the measurement works later. So I'm going to apply that. We now have our material. And now it's time to get to modeling the part. So on the drawings, the first thing that I noticed is they also like variables. And variables are a thing I don't use much. I often, very often use equations, and it just so happens they're in the same spot. So first of all, and actually maybe I should have left that part open. Where did I save it? Let's see. Maybe I should have left it open just to show some illustration. Yeah, we'll find it later. Anyway, um, so the equations are going to come from tools and down here under equations, and we have options. So equations, when we use them, will pop up here. So let's divert for just a second. This is how I can enter. So for instance, I know like the overall length of that part, or at least one of the dimensions defining the length, is going to be a global variable called A, right? And they'll give you right on the drawing, they will give you dimension A, and then in the problem statement, they'll tell you what A should equal. So I'm going to set this for now, let's call it 100 millimeters. All right, so I now have a global variable that I can use later in a sketch that is 100 millimeters, right? So I'm going to click OK. Now that I click OK, I have equations over here on the sort of the left-hand side. Now I'm going to divert just a touch and go to my top plane. I'm just going to create a quick sketch and show you how I sort of normally would use an equation. So I was familiar with, I'm not, again, not ashamed to say I've never used a global variable the way the test asks for, but equations I use all the time. And this is just a simple example. This is not the part that I'm going to be drawing, but if I dimension this, and let's say I give this a length, um, and then I give this a length, but I want this to be sort of always locked to that 75 millimeter length. So what I can do is click to add the dimension. If I type equals and just click, let's click off so my drop down is not stuck on. There we go. And just click the 75. I get an equal, and in quotation marks, I get D1 at sketch one, right? That's this dimension. So if I hit enter, now I have an equation symbol, and I can toggle this. It'll tell me what that is, or it'll tell me what the equation is. So I can see what the actual value will be. Um, so I use this quite a bit, quite often for, say, hole placement in a hole pattern. If I know that they're all equally spaced, I'll just do a bunch of, I'll drop my points in here for my hole wizard, and I can grab that as many times as I need to and just say equals this dimension, enter, and height as well equals this dimension. So then everything ties back to that one dimension. That's how I can maintain an equal hole spacing and know it's always equal. So this I do all the time, the equations. And then to see those, if I right click on equations in my feature manager, I can manage equations, and I get all of those equations here, right? Listed under equations. I've never actually needed to use global variables. It's okay. It's not a bad thing. It's just a thing that I haven't run into. So that was different as far as the test was concerned, but it is a thing. So I'm going to okay this, and I'm going to go ahead and delete. Actually, I can just discard my sketch. So I'm just going to, deny the sketch. Now, if I go to manage equations, those equations are gone, but my global variable stayed. So I also know that they had a B variable, or that we will need a B variable. Let's call that 25 millimeters. And like I said, I'm making this up sort of from memory, but oops, we don't want double equals 15 millimeters. Um, I'm sort of making this up for memory, but what this will end up is A sort of defines the length. B is going to end up being some of the dimensions that define, B and C are dimensions that sort of define the triangles that you might have seen at the beginning of the video on either end of the part. So that's where those are going to come into play in a minute. So I'm going to accept that. I'm going to click OK. Then on my top plane, rather than do a triangle, I'm going to do a square extrusion, and they will usually say in the problem statements that I had anyway, that it doesn't really matter where you put this origin. And that's true. There are some cases where you will want to pay attention when you're creating the parts to where this lands, because it will make more sense in some places rather than others when it comes time to dimension. But other than that, I mean, it's truly arbitrary. So I'm going to go ahead and create a square, and I'm going to do a square part rather than a triangular part, or rectangles, I should say. So I'm going to smart dimension this. And if I set this equal to B, oops, we need, all right, so that is a good error. See, I'm so unused to this. So if I just say equals B and I accept, see, it won't even let me accept. But if I throw that B in quotation marks and hit enter, now I'm locked. It's grayed out. I can't edit it, right? I can switch back and forth like I did with the equations, but I'm locked. It's now 25 because that is what B is. So if I do the same thing down here, equals quotation marks B, enter. All right, I'm locked in to that 25 millimeters. Now that triangle had a wall thickness, and I can now use the same thing for sort of the thickness of the walls, but in this case, I'm going to use C. That was the smaller dimension, and I made it way too big, right? This is the joy of, designing things on the fly with no clear plan. So I'm going to manage my equations. I'm going to drop this guy down to 5 millimeter wall. Okay, we're good there. And I'm just going to go ahead and do that on all sides. Equals, make sure to use the variable. Enter, and do this all the way around, equals C. Except equals C. And for the most part, this is relatively easy so long as we can sort of envision what this thing needs to look like. So now I need to extrude this. I'm going to extrude it 50 millimeters. And I don't need, remember, since I changed 2 millimeters already, I can just type in 50 and get 50. Now I don't want mid-plane right now. Mid-plane SolidWorks, remember, just remembers the last thing you did. And since I was in there doing parts for this exam, the last thing I did must have been a mid-plane. So this one I want to do blind. I want it to be entirely above my plane, and I'm going to accept that. So I've got the square on one end. I'm going to go ahead and create the one on the other. Now, if you remember back to the beginning of the video, if I sort of move this to a side view, the bottom plane of that other end was somewhat below this one. So how do we go about that? It's been an arbitrary value, by the way, because the extrusion height wasn't even the same. So what we can do is we can actually create reference geometry. And that's the thing that I haven't gone over in a video before. I sort of mentioned it, but I'm going to select my top plane, and it's highlighted, and that's what I drew this rectangle on and then extruded. Then I'm going to come up here to my ribbon and click on reference geometry, and I'm going to click on plane to add a plane. So notice it wants to create this plane. This blue outline is sort of the preview. It's going to create it 6 millimeters from the top. I'm going to go 20, but then I want it to be below. So all I really have to do is flip the offset, or I do believe if I click, nope, that one. Some of the tools let you click this icon sort of next to it. But I'm going to flip the offset. It sets it below. Now if I hit OK, I now have plane 1, which is below my top plane. So I'm going to go ahead and sketch on that. Actually, I can start right with an extruded boss base, and I'm going to come way over here, and I'm going to sketch my exterior first. And I actually probably want to go back and make that bigger in the first one bigger, but we'll see how it goes. So let's go 20 millimeters. I don't remember what I did on the first one. Let's go 20 millimeters. So we've got a square. Now these things need to be in line. It was a straight part. So I can grab just sort of move my mouse over till this goes orange. And in the middle, I can wait till I get the icon for center line, or center point rather. I can drop a line from center to center. Remember to make that for construction. And I can fix it to be horizontal. Now those two things are locked horizontally, right? And then the distance between them is what I want to set as A. So I'm going to set this equal to, don't forget the quotation marks, A. Enter. Okay, that's all right. And then I'm going to add my little interior feature here. And I'm also going to set that to the same wall thickness equals C. And I'll do that again all the way around. So this part, I will admit, as I was taking the professional test, this is the part that I spent the vast majority of my test time on, just because I frankly ran into things that I've never done before. So it took a little bit of trial and error to figure out, how things needed to be done to match what they had. The good news is, with a little bit of experience, I was able to figure out, sort of the cleanest way to do things, um, to get a good result. So I'm going to extrude that slightly less, just for the sake of display. Now, the tricky part, well, really, the main tricky part was the fact that these are not the same size, right? And not on the same plane. So we have a couple of choices. There's a couple of different features here. So a boundary boss or base um, is a little bit like sketching a line and then sort of extruding a thin feature, almost like a surfacing tool. We could do that, and I tried it. The problem was it doesn't give a consistent cross section. Um, so the thing that I found that worked the best um, was to just do a sweep. And the easiest way to do that is on my front plane. Well, this is where it would have come in handy. So it would have come in handy to pay more attention to my coordinate system, but this is good. Now we can, learn how to sort of edit the things that we've done. So I'm going to edit this sketch. I want to break this coincident um, dimension here, and I'm going to slide this down, and I'm going to select the line and the center, or the origin rather, make that coincident. And actually, I wanted midpoint, but either way. So make it the midpoint that way. And notice, because I drew that construction line, locking these to be horizontal to one another, this moved down with it. So now when I grab my front plane, it's in the center. And what I want to do is I want to sketch sort of that bottom feature. And I want to sketch the path that it's going to take. And they will give you, they'll give you drawings, right, with dimensions to sort of show how that goes. So I'm just going to make it up. And I'm going to keep it fairly simple compared to what they had, but I'm going to draw here to here. I'm going to keep it simple with one angle rather than a double angle like they had, but you get the idea, sort of the thought process behind. Come here. We want to grab this point and make sure that now it's better for the plan. The plan is to sweep. So it is better in this case, when you're going to sweep, it is better to use, if I hit coincident like I have been, I'm on that line. Sometimes that is not good enough for a sweep. Sometimes a sweep wants a pierce. Oh, okay, so we don't intersect, so we can't do the pierce. Occasionally, the sweep will make you do a pierce instead of a coincident. And that just is in my layman's terms, just another way to make sure that this is on this surface, rather than just coincident with one of the lines. But for now, it doesn't look like it wants me to do that. So now that one, it did let me pierce. In fact, that one, I can't do coincident. I have to do pierce, maybe because they're on the different plane. So I'm going to delete that. Oops. I want to delete probably that one. That's right, because I grabbed the vertical here. Let's grab this one and pierce, just to make sure that my sweep is happy when I go to use this, because what this will end up being is the path for my sweep. So then I am going to add an arc here and an arc here. And these will end up being sort of like fillets. So constrain them to be tangent to the two lines. This one tangent to this upper line. I'm going to draw a line between them. And I'm going to make that tangent to the arc as well. Tangent to the arc as well. I'm also going to grab these two and set them to equal. Maybe not the best way. The trick is you're going to have to look at the drawing provided to know whether those two curves can be equal or not. Because eventually this thing is going to end up with a thickness, and depending on whether this is an inside bend or an outside bend, that radius might change. So they may not be equal. For the sake of me just making this up, this is good enough. But maybe not. I mean, it might not be good enough, right? So that's actually all we need for that sketch. Like I said, that's going to end up being our sweep path. Then we need a sweep profile. We need the shape that we're going to sweep. So on the big rectangle, I'm going to create a sketch, and I'm just going to click right into my sketch with the rectangle tool. I'm going to draw a rectangle like so. From edge to edge, it's coincident with both edges. That's fine. That's what I want. And then I'm going to dimension this guy, and I'm going to give it a, let's call it 6 millimeter height. Okay. So I've got now my profile and my path for a sweep. I can just click on this sketch. Actually, feature tree is better, feature manager. So click on the sketch for both, and then go to features and swept boss or base. And you can see it'll sweep that right along. So I'm going to go ahead and accept that. Now, there is a problem here, namely, right here. In that part at the beginning of the video, this thing was angled from the top from the big, this was a triangle, but from the big triangle to the little triangle, this had an angle in it. So the best thing to do there, or at least the way that I did it, because sometimes there may be a cleaner way, I don't know, but sometimes brute force just works. So what I did was I just cut that off using a cut, and it was relatively simple. So on this, I might as well go on this plane. Let's do a sketch. I'm going to grab a line. And because of the way we're drawing things, sometimes SolidWorks reorients us. It doesn't matter. But let's grab this corner and this corner. Okay. And that's really all we need for that sketch. Now, if I click on that sketch and if I do a feature extruded cut, notice it's going to cut all the way down. Now we need to pay attention to both of these arrows. So these arrows sort of tell us, which way it's going to extrude that line we drew. This arrow, the small arrow, is going to tell us which way it's going to cut. So if I accept this, it cut out everything on that side of the arrow. So we need to reverse that. So I'm going to undo, select my sketch again, do an extruded cut. I want to flip side to cut over here in the properties. Flip side to cut. Now the arrow is pointed out, and it will cut off everything outside of that line. So I'm going to do the same thing on the other side. I'm going to do a sketch, grab a line, and just go corner to corner. Corner to corner, except I'm going to grab that sketch and do a feature extruded cut. And it's already set to cut off on the side I want. So accept it. And now we've got our angled. Now you can't really, I mean, it's hard to tell maybe because of size of things, but that thing is now angled, in from the big rectangle to the little rectangle. So the next thing is this thing had a big rib running along here, a stiffener if this was some kind of bracket. So we need to do a rib. I mean, a rib is effectively an extrusion that is thin. So a thin feature just means we don't need an enclosed shape, like we don't need a rectangle, we just need a line. And it's going to take whatever shape we sketch, and it's going to extrude that down to the rest of the part. So what does that mean? I might as well do it. So let's go on the front plane again, and we're going to sketch something that looks an awful lot like this original sweep. Um, and so I'm going to go to sketch. I'm going to turn this again because I want to be able to pierce when I get done. So I'm going to come here and I'm again just making dimensions up. I mean, I'm just drawing it again from memory. I didn't want to match the part exactly because one, I don't want to run afoul of any copyrights, but two, I mean, the whole point of the test is to prove that you know what you're doing, right? And I don't want to sort of compromise that. So let's tangent everything. Everybody's tangent, more curves. So I figured the best way to sort of go would be to go through, the techniques more than the techniques more than the exact parts. So make everything tangent with the curves. And again, pay attention to the drawings. They'll give you all the dimensions that you need. I'm going to pierce these edges again. Pierce. I'm going to set this to be horizontal. Okay, so now I'm going to leave it blue. Now, normally I recommend, actually, I'm going to, one more thing just for the sake of completeness. I'm going to make these equal radiuses. But I'm going to leave that blue. And normally for my students, I would tell them that everything they give me, turn into me, has to be locked down. It has to be fully constrained. But for the sake of this, since, especially since I'm making it up on the fly, we don't really have to worry about that. So I'm going to accept the sketch. And on my features now, I'm going to come over to the rib tool. And the rib, like I said, it's going to take this sketch and it's basically going to extrude it as a thin feature down to the model. So I'm going to click on rib. You'll kind of see what I mean. So this is showing me the thickness and it defaults over here to 10 millimeters. I'm going to drop that to 5. So it's showing me the thickness and the arrow showing me it's going to extrude this way and it's basically going to stop when it hits the part. So if I just accept, I have a rib. I mean, just that simple. That's as fast as it is. So basically it's the sort of the shape of the top of the rib and what direction do you want the thing to go in, right? The thickness to extrude on either side. But that is basically it for the rib. And then so we come to sort of the final, say, part of this, the part that was on that exam. They wanted it modified then after we sort of reached this first stage. They wanted it modified to add a boss with a screw hole in it. Which is a fairly easy thing to do. So we'll go ahead and do that. So I'm going to grab this outside of the big square because that's now, if I look at it from the top, that is now the most outside surface I have, right? The most outside surface I have. So I'm going to sketch on that, sketch. And I'm just going to draw a circle for now. And I'm going to leave it well, let's not leave it completely undimensioned. Let's give it some. All right. And then I am going to feature extrude that guy. I want to flip it. And in this case, I want to go up to surface and I'm going to select the other side of the square. So it'll just stop at the other side of the square. And I'm going to accept that. So now that's in there. And I mean, you can do this same technique with more complicated geometry, it's fine. But now I've got a problem because I have, the cut was done first. And since I extruded from this outer face, I have a bunch of extra material here. And on the test part that they provided, the drawing, this face followed this contour. There's a couple of ways that we can make that happen. One way is literally to just grab this boss and drag it up above our cuts. If I just drag it up, see how it merged in now and it cut and we lost that extra material and everybody's happy. That is one of the things that it can be tricky to do that, especially if you've got, dimensions to some of this other stuff. Like the location of this boss matters. And when I punch a hole through it, the location of all that matters. So I'm going to go ahead and grab that boss and I'm going to delete it because once it's, like I said, I'm going to, let's see, delete, absorb, that get rid of the sketch too. The we're going to end up with dimensions placing that thing, right? It's defined. I just drew it in there and left it unconstrained, but it's going to have dimensions. And depending on how we dimension to this and how we dimension to this, modifying a part can pretty easily break other things. So one thing that I kind of recommend if you have to make a modification like that, right, is I would straight up. So we've got our sweep, that's the bottom. We've got our rib, right? I would grab this here. See where the over on the feature manager, if I go over this thick line sort of at the bottom of my model tree, um, and I get that hand icon, if I click and drag that guy up, that's called rolling back the model. So it basically undoes everything below it, which is just those two angle cuts and the rib feature, right? So I can roll back the model. I can safely dimension to this now. And then I can roll the model forward and it'll maintain everything and it makes it less likely for things to break because I suddenly cut away a feature that had a dimension on it. So I'm going to do it that way instead. And I'm going to grab this same plane. Now, all of these faces, by the way, are in the same plane, right? We haven't cut them yet. And I'm going to do the same thing. I'm going to extrude on that plane. I'm going to extrude a circle, overlap it a little. I think I called it, what, 15 millimeters. So it overlaps a little so it'll stick in. And again, the geometry in the actual test is more complicated and it is fully constrained, but same idea, right? I'm going to accept that sketch. I'm going to do the same thing now up to surface. I don't have to worry about direction necessarily because when I select the surface I want, it's going to automatically flip it. I'm going to accept that. And now when I roll the model forward, now I got effectively the same thing, but less chance of breakage just by dragging something up above. So for instance, if I drag this cut up above, like it won't let me. I can't put it because I need that sweep in order to cut. But to avoid things like that, it's easy to roll the model back. I can make my changes, roll the model forward. I can do all kinds of stuff. So I'm going to also add the hole just with an extruded cut and a circle. And I didn't hit the center. Pay attention and hit the center. Just slow down, grab that, get the center. There we go. And again, I'm not constraining anything because, um, I mean, really, I'm making it up on the fly anyway. I made up all these dimensions. So I've got my through hole. Now, if I drag down, see the rib, because it now stops at the boss, it doesn't include this, the hole. So the rib does not extrude through this surface. It extrudes right up to it and is actually part of it. So, and then sort of the final thing that I don't think I've reviewed in a previous video is sort of the grading method. The way that they make sure your part matches theirs is by mass. So effectively, we're going to weigh this part, and if we have gotten close enough to sort of their target mass and the way that they modeled it, then we should be able to get the same mass that they've got, right? There's a number of different ways you could do what I have here on the screen and get the same results. So rather than get picky about following an exact process, I actually kind of like the idea of looking at the mass of the thing, um, because that'll tell you whether the geometry is right or not. I mean, I could have done this with hundreds of more features, right? As long as the mass is the same, that means or gives a pretty good indication the geometry is the same. So to get to the mass is fairly simple. We're going to come up here to the Evaluate tab on the ribbon and just click Mass Properties, right? So this is the mass in grams, 492.49. So that's what I would enter for my answer. It's just that simple. So again, mass properties on Evaluate, and that's it. And if it's not in grams, for instance, if we forgot to change that density when we assign the materials, we can always click Options. We can use custom settings for units and just change mass right here. We've got all the choices. Um, so yeah, that's just typically what they will be asking for when it comes to parts. Now, when it comes to assemblies, I will warn you that they do get a little tricky and start asking for the center of mass, in which case they're going to want all three, X, Y, and Z, dimensions, which is, fairly easy to get from the same place, right? Evaluate mass properties, you get the mass, you get the volume, and then this right here, center of mass, because in assembly, just like the overall mass of a part in an assembly, a good way to sort of check you without getting into every detail is, well, is the center of mass where it should be? So hopefully this helped. Like I said, just some tips and tricks without getting into the, exact parts that are on the SolidWorks, the Certified SolidWorks Professional exam. So I wanted to go through that. Hopefully this helps you out, helps some of my students out. And thank you for watching, and I look forward to seeing you in another CAD video.